So let's go and do some code. It's always better that way. I'll go right here and I'm going to create unit 10. And I'm going to create two packages. Okay, so we'll demonstrate that protected field access modifier, how that works and how that doesn't work. Okay, and how you can also actually access other classes from other packages. I think we haven't done it before yet. Usually you create a package. Again, that's just a directory. We always use that term namespace. It's the same thing. Okay, it's the same directory, same location. So let's create a package in here. I will call it just package A. Call it, package A. Call it big A. And we'll call the other one just package B. Okay. Sure we don't have any questions over here. Okay. All right. So in the package A, we will create a class. I'm going to call it, because I will use, I'll create two classes in the same class, right? You could do that, right? Remember, if you remember, like a couple, I guess, weeks back, I will call this one here class A. Let's go class AB, because I'll put both in here, and yeah, we'll put a constructor in here as well. I mean, a main method. So we'll assume this is the main function. You can choose any one, but I'll choose this one. This is the main program. So the package is up here, package A. Because of this directive package A, that means if I have other classes inside the package here, I can just use it directly, right? I don't have to reference package A dot whatever the class is. Okay. So let's go right down here and the bottom here. I'm going to create another class. We'll call it class A. And this class A, for now, we'll just put class A here. Below that, we will create another class called class B. And this class B will extend, actually, no, we'll keep it this way. Sorry. I will make A extends B, then B extends C, and so on, right? It makes more sense that way. Okay, so it's a little bit smaller. Okay, so in the A class, we're going to create a constructor. So this will be just public A, right? Inside this constructor, we're just going to put a message to show that when you instantiate an object called A, it's going to say A has been created, right? Or something like that. But I'm just going to say SOUT. I'll call it just in a message so we know. We just say constructor A. And then put a slash n so we know it's, well, I mean, you don't have to, sorry. The print line already does it. That does not put a print line there, but so that's the constructor A. And we'll do the same thing for B and C. So we'll go down here again, put a public B constructor. We'll put SOUT out constructor B. So now I'm there. There's completely three classes. You've got the class AB, have a class A, and then class B. And this is completely legal in Java. I mean, it may not be recommended, but in terms of just testing it out, you can easily do this. You don't have to create separate classes, separate files. Okay, so now in the main program, we're going to instantiate an object of each, right? So we call A is equal to new A, right? And B. So just typical object instantiation of those two classes. And then inside the, let's just say inside each of these class, we're going to write another function, and we'll call it public void and then print. Okay, void print, and takes no parameter. We just again print another message. So we show that it's a function belonging to class A, but we'll copy that over to B and also to C on the other side. So again, system out, we'll put print A. So I know that it's from the print A, from the A class. You just copy that over to the B class, and we just call that print B. Okay, so you save those, save the file, and we're going to create print those two statements. So we're just going to say down here a.print and b.print, right? So it's calling each own method, but they're not forming any type of relationship. So if you execute that program, you should see constructor A when we call the A, when we instantiate the A object, and constructor B because we instantiate B object, and then they print their own methods, print A, print B. Okay? Again, that's pretty typical. So the next thing we're going to do is I'm going to extend A. So this is how you're going to create a relationship between A and B. And when a class that has the keyword extends, and that class is the child class, right? It's always the child class. So we'll make A the child class of B. So we'll say A extends B. Okay? So for example, I mean, you cannot do a loop. So I can't say B extends A. Okay, so you formed a loop, and that's illegal. So you see you have a red line there, tells you that it's cycle exists in the type hierarchy between A and B, so it doesn't allow that. Okay, so B cannot be extending A. Okay, if you save that, if you print, if you run, you still get the same result, I suppose, right? Except you get one thing here is different, which is so what's different here? I didn't have the other one before, but I think if you remember before, we had just these 4 lines, right? We didn't have the first one.
Because it calls the constructor from class B first, and all class A.
Right, right. It always calls the parent constructor first, and then it calls its own. So line 7 here, right? It does 2 things. When you call it, these 2 lines here are actually called when you instantiate object A. Right? Because object A extends B, so it will go to the parent's class. If it has a constructor, usually they all do, then if the constructor does something, it will do whatever it's need to do there, and then once it's done, it will come back down to the child class and then call its constructor. So A does this 2, and the B, because B is itself, it does just that part, and then these are just normal. Okay. So the next thing is, let's say because A is a child class of B, so that means I can say I can turn this off, because I assume that if that's the case, the what I just did here is basically I'm overriding B's method, right? B has a print method. A has one too. So really this print method is overriding. I'm overriding B's method. So that's why you see print A when I show the print A print here. If I were to turn this off, okay, if I turn this off, if I just select it and do a control backslash, comment that out, you'll see that there's no error, right? It's completely fine, even though I say a.print here. And we don't have a print method in the A. But because of inheritance, it's going to go up to the B class and use its method to execute. Okay? So if you save that now, if you run, you will see that you won't see this print A anymore. It'll be coming over from the B only. Okay, so the A object instantiate and execute the constructor for B and A, and then execute from the B class. Okay, so and the same thing for B. For B, just a normal. And if I were, let's say, if I do a comment here, if I turn it back on comment. So again, here you didn't see the override thing, but usually you can put an override here. The override keyword here, and it will override to show you that you're actually overriding the parent's method called print. Right, just a notation to help you. And again, the rule says the child method, if you override, you can see the overrides here. If you mouse over, click that and you look at the menu here. So it says you have to have the same name and same parameter. So the parent has no parameter. If I put here, if I just had to say int a or int I, right? So it will fail because now the rules has been violated. Okay. Overrides, you must have the exact same copy of your function definition here. Inside the body here, it doesn't matter. You can do what you want because that's what override is. Right? You override all the commands from the parent. But the function declaration cannot be changed. Okay? It has to be exactly the same. If it has an int, you have to put int here, even though you use it, whether you use it or not. You have to put that in there. Okay? So that's just the rule of override. So this is called the method override. If you don't want to use it, then you have to call a different name. Okay. What if I want to do something like this? If I want to just copy this, put it here, and I put int a. Now it allows me. Why is that?
Now you're overloading child build method.
Yeah, right. So you can see how this is also useful but also confusing at the same time, right? So one of those has to be the one that is coming from the parent. Once that has been established, then you can create your own copies, or you can actually overload that with different parameters. When you do that, though, it's no longer the parent's method. It's just the class method itself. Okay? So, so that's, again, that's overload, and then the other one is override. All right. So now, if we just prove that when you create a class, an object, it will always go to the parent's method first, class first, execute its constructor, and then comes back down to the child class. So we say well, A extends B, and B extends C, right? So we can go here and put extends C here. Extends C. C class doesn't exist yet. We're going to create it right now. Let's save that. So let's go over to the other package. I should have called this package C. Maybe we should do that. Okay, I'm going to rename this package B here. So you just like right click on it. Let's see if we let us do it. Refactor and then rename. And we'll call this, let's call it package C. And just click OK. Okay? That should be. If it's not, just delete it and create another package. Okay, so in package C, we're going to create a class C. So create a new class. Just call it class No, we just call it just C. Okay, just a capital C. No main method, just a class. So here's class C, and its own package called package C. So we do the same. We're going to create a constructor. Not double constructor, of course. Public C, and we're going to sys out constructor C, and it's going to have its own print statement, right? So public void print, again no parameter, and just again sys out print C. Now notice that C is its own package, so its own separate directory. In order to use any class constructors or functions or use that class in your other package, you have to import it. Okay, so if you go back to the class AB, notice again C here, just say there's no C class. And they ask you to import because we have one, right? So this is identical to how you create the scanner class or any of the existing Java classes. If you have one, if it exists in your program, it will find it and it will make that available. Here you just import that class. It's in the package C, it finds it. If I were to rename it differently, it will not find it, it doesn't exist, okay? So if I put, for example, change to class D, there's no class D. And it asks you to create one, right? But class C, we have it, so we can go ahead and just click import C. And if you look at the very top, we have imported package name dot class name. This is very similar to the scanner, right? Import java.util and so on. Because Java is a class. It's available to every in your program. So if you save this, so all the access should go away. Everything's happy. So now you have access to class C data, and because A extends B, B extends C, so therefore A has everything in B and C in itself. Okay. So if you print now, and if you run, you will see that now when you instantiate A has to call C and then call B and then call itself. So it calls all the way from, in this case it would be the grandparent, and then call its parent, B, and then call itself. Okay. It goes up to the root and then it goes back down the chain to its own constructor.
So how did you get it to extend to class C?
I'm sorry?
How did you get class A to extend to class C?
Oh, because class A extends B and then class B extends C.
Okay.
Yeah, you must have missed this part. And then C is in a different package, right? So right now I could say if I turn off B, the print command for B. So if you go to B and you comment that out, the print from B. So when you call A.print, A has its own. So A is going to call print A here. And when I call B.print, B doesn't have it, so B is going to call C's print function, right? It goes up the chain. Okay, so I turn the print off of the B, and I save that. If I execute this command, this program here, we'll see that these 3 lines are called from line 9 when you instantiate A, and then these 2 lines are from line 10 when I instantiate B, because B calls C also, right? And then calls B. When I print A, it prints its own because it has one, right? It has its own function. But B doesn't have one, so B is going to call C's function, print, to print it. Okay? So B will never call A because A is the child of that. And too bad there's no way to call the child's methods, right? I'm sure that's done a ton of studies for that, and it causes problems. That's why. But yeah, you don't have that option. So here, when I print, so let's say in the A class, when I call the A.print, so we call it A.print. A is calling its own method here. And you can force this print method to call the parent's method. And avoid, and plus your own. Okay? So for example, you're going to call the parent, you just basically say super.print. Okay, the super means it calls the parent. And if B has it, it will call B's method. If B doesn't have it, it's keep going on the chain until it finds one. So in this case, it's going to call C's method, right? And C would say print C, and then after that line, it's going to call its own because it still has some commands to execute. So it was to say print A. So you would wonder, why would you do that? Well, maybe because, like just say in the parent class, you might have a different statements, different way to print things out, or a different calculation for whatever that method is. And when you have an input coming in, like in this case, right, let's just say that A comes in, if you check A. If A is a certain value, a certain range, then you print your own local statements. If it's not, you call the parent's method to execute, right? So you don't have to do two calculations in the same method. Okay, so it's almost like you take a partial from the parent and a partial from your own. Okay? So let's say this is true. To save that, for execute, and so you see that again, this 3 lines here is from A, line 9, this 2 is from line 10, and then when I execute line 12, it prints the constructor from C. This is the grandparent, right, method, and then it prints its own local method here. We'll just have that remaining statements, and the print A, and then the B print still prints that last statement here. Okay? All right, so let's do one more thing about these access modifiers. Now, if I go into, because A is the child, the parent is B, so if I go into B and we're gonna, okay, I'm gonna turn the B print back on. I'm going to turn off both of the A's. Here I have 2 of them, so if you have one, just turn that off. So A has no print statement anymore. And A will call B statements because we established that relationship, right? So when I do A.print, it's going to call B's. But inside the B method here, instead of public, I'm going to change it to protected. Okay. Oh, actually, no, I can't because, I can't because now I'm violating the parents because I'm overriding that. So let's do a different method because I don't want to cause that issue yet. So just create another method here for B. Let me just put some extra lines down here. So for B, we'll add another method here. We'll make it protected void. We'll just put message, okay? And I'll put a message, I'll pass a message to this as a string. So we'll put a string MSG here. And then we'll just system out a message. So sys out a message. So it's protected. It will be different. If it's private, it will be different. If it's private, then it won't be able to call it. Well, I think you can. Let's see. But protected, let's save that. I'm going to modify my code up here. So after A print, B print, and then we'll do A dot message. Then we'll put a string here. Hi from A. So that should be the last statement. Okay, so you execute. And so here is the last message, right? Hi from A. So you can see that even though it's protected because A is part of B, then it's allowed to call that method. And again, because A and B are in the same package, right? Package A. Now, what happens if you change the same message to private? You change that message to private. And, right, so you see again here, it's not visible, right? So that class rule still applies. Even though A is a subclass of B, it tries to call B's method or message because message is now private, only B can access it. Okay, so that's being very private to its own class. If you want to leave that little bit the privacy out so that only your child classes can access, then change that to protected. Okay, so that is still very private. If you change that to protected again, that should be fine. Now, let's just say that we're going to, I'm going to create this same function here. I'm going to copy this function, the void message here, to the C class. Okay, we'll add it to the C class. And we'll call that protected as well, right? Protected void message. And I'll remove that from the B class. So now because of the inheritance, right, it should, because we proved that we can actually access C's print method. So in here, I'm going to turn this off from the B class. So when I print the A message, you see that it already has an error. Okay, it won't let you access it because of that rule. The protected must be the classes must be in the same package. Okay, because it's in a separate package called package C, then therefore it doesn't allow that. Okay, so the only way to access it is if you make it public. Okay, so therefore it fails. Until you overwrite it, right? If you overwrite it, then it's fine because now you're actually overwriting the parent, which is the C method or message. I override that inside the B method. Again, the same rule applies to overriding. And if you execute, it should still work just fine. So you can override it if it's you're accessing a cross package, or just set to public. Okay. You guys have any questions? Good. That's awesome. All right. So because we can access the parent's method, we can also access the parent's constructor, right? Let's see, put that here. No, super Oh yeah. So yeah, this, well, we know that the this, right? This refers to only objects or only like methods and properties of the same class. In this case, it would be class A, right? Mentioned in the notes. And super will actually call the parents class. Again, up the chain. It goes up until it finds whatever needs to be done there. Constructor. Okay, so when you have like a constructor, let's see. So how here I showed you how you can actually access the a print method from the parent class using the keyword super.print, right? You can call a parent constructor also in the constructor class. Method inside A, for example. I can pass data to the parent constructor. In this case, constructor B has no parameter, so it's going to pass. Basically, I'm just doing a call, right? Even though I don't call it, it will call it anyway. We saw that. It's there, it's just not visible. Okay? It usually calls at first, and then B will actually call C and so on. So if B has a parameter, like, for example, if I put B here, takes a parameter, let's create another constructor in B here. We'll call it constructor B. Take a parameter. We'll just call it another string str, and I'll just system out that print statement here. Again, I'll put constructor B, and then I'll put a message here. And then we'll plus the string. Okay. So you have two constructors in B, right? Again, when C calls and when A calls B, it's just going to call the matching constructor. It's not going to call all two constructors, right? Okay. If you don't explicitly call it, then it's going to call the blank one by default. And we show that that's how it works. So even though if I do this, if I call it super from the A constructor, super here, right? It's going to call the base B constructor, which is the blank one, and you should see that the same thing happens. It just, if you run, you just see constructor A, constructor B, right? It calls the C. Actually, A calls B, B calls C, C ends there, so it prints C, goes back down, prints B, and then prints A, right? Now, if I go here, put a string, just say from A, then it's a string, so it's going to match the second constructor and not the empty constructor. So I'm expecting when it prints B, we'll say print B message, and then from A. Okay, we'll save that, see if that's true. And go ahead and print that. Right, so you see that A calls B. When A calls B, we call a different constructor, not the default one. We call the one with the string parameter. And then from B, it calls C implicitly, and then comes back down and prints the message out. So we got A here, and then back to A, and then so on. Okay. So this is useful. This super here is very useful for cases where you have some parameters in the A and some parameters in the B, right? Because maybe B is a class that is more abstract, that can be shared by other subclasses. So when you have something like that, then you need to, instantiate A, and then fill all those data in the A class. Sometimes you want to separate them out.